Hello guys, this is a video solution to example tutorial sheet number 4. This tutorial sheet has 7 questions. 7 questions. So we'll go through each of them and give you a detailed solution, right? And I should emphasize that this video solution is on top of the typed solution, which you can find on the course website. Alright, let's start with question 1. Question 1 is, you have this data, 25 data points, and we want to know how to compute the quartiles Q. Don't know if you can see this, but okay. We want to know how to compute the sample quartile Q of P at these values for P, right? Now, if you look at the lecture notes, I gave you a formula for computing this guy here, and let me remind you what that was. It's this one here. This is the. If you look at my notes on the videos on summary statistics, this is the formula that I gave you for computing Q of P, where these are the data in arranged the sorted data. R prime is the integer part of P times n plus 1. R is P times n plus 1. Right? So I'm going to use this formula to answer question 1 and the other questions on this sheet. Right? Okay. So here the data is already in arranged form, so you don't need to arrange the data, because it's already in arranged form. So the smallest data is this, the largest is this one. Right? All right. So let's see how we can do this. So the first thing we want to, so this is question 1. We want to find these values. Right? We know that n is 25. Okay. So in order to use the formula for different values of P, right, we need to compute R and R prime. Right. So let's start with P equal to. Let's start with P equal to 0.1. So your R is P times n plus 1, so it's P times 26, which is 2.6. R prime is the integer part of R, so it's the integer part of 2.6, which is 2, right? So if you use the formula that I just showed you, let me show you one more time. All right, this is the formula for the quartile, the pth quartile is given by this, right? So Q at 0.1 is given by X at R prime, which is 2, plus R minus R prime, which is 2.6 minus 2, which is 0.6. multiplied by X at 3 minus X at 2. Alright, so this is the formula, just using the formula that I just showed you. Now X2 is the second smallest value, which is this one, right? X3 is the third smallest value, which is this one, right? Right, so you should just use them, right? So X2 is 0.2290 plus 0.6 multiplied by X3 is the third smallest, which is 0.6390 minus 0.2290. Okay. Now if you compute this, guys, you get is equal to 0.475. So this is the 10th percent quantile for the data set, p equal to 0.1, right? Okay, now let's repeat this for p equal to 0.25, right? So repeat this for p equal to 0.25, right? So your R will be this, right? So that will be 6.5, okay? And your R prime is the integer part of R, which is 6. Okay, so 6.5 minus 6 is 0.5. Okay, and so this is the 6th smallest data point in the data set. So if you go back to the data set, so this will be 1, 2, 3, 4, 5, 6. It will be 1.8529, and this is the 7th smallest data point, which is 2.3581 minus 1.8529. All right. As you do the math for this, you will get this to be equal to 2.1055. Okay. All right. So this is the quantile for p equal to 0.25. Okay. Next, we need to find for p equal to 0.5. Okay. So let's see how we can do that. P equal to 0.5. Okay. So your R will be 0.5 times 26, which is 13, right? And your R prime is the integer part of 13, which is also 13, right? Now you should use the formula that I gave you in the class. This will be x 13, right? Because r minus r prime is 0, the rest will be 0, right? Because r is the same as r prime, right? Now x13 is the 13th smallest data point in the data set that you're given, and you should find what that is. That will be equal to, the 13th smallest data point is 2.8957. Alright, so that's for p equal to 0.5. Next one is p equal to 0.75. So let me do that on a new page. So this is p equal to 0.75. So your R will be 0.75 multiplied by 26, right, which is equal to 19.5. Right, and your R prime is the integer part of that, which is 19. Okay. Alright, so your Q at 0.75 0.75 is going to be, if you use the formula in the notes, is x at r prime, which is 19th smallest data point, then r minus r prime is 0.5. Okay, this is what you get, right? Now, if you enter the numbers, this is what you will get. This is the 19th smallest data point in the data set, which is 6 point. Okay. Now, if you do the math for this, this becomes 6.15. Okay. All right, guys. So this is the 75th percentile or the 75th quartile of the data set, right? All right. All right. Now, next is we want to find the one corresponding to p equal to 0.9. So your r will be 0.9 times 26, which is 23.4. And your r prime is the integer part of this, which is 23. Alright, so this is q. Your r minus r prime is 0.4. Okay, this is what you get. Alright, so this is gonna be equal to 14. If you look at the data set, this is the 23rd data point, the 23rd smallest data point. And this is the 24th smallest data point. Okay. And if you do the math for this, you will get this to be 14.53384. Alright, so we completed all the quartiles that we were asked to find. Okay. Alright, one other thing that you're asked to do is the following: that use this information to, I don't know, you can read this. Use this information to deduce whether the data are sampled from a symmetric distribution or not. Okay. Now, if the data are symmetric, then you would expect. If the data are symmetric, you would expect the distance between the median and the first quartile to be equal to the distance from the median to the third quartile. So if the distribution is symmetric, then one would expect the distance of the median. Remember, the median is q at 0.5 minus the first quartile is this. This is the first quartile. You would expect this to be equal to be the distance from the third quartile to the median. All right. you would expect these two numbers to be approximately equal, right? But for what, according to the numbers that we got, right? This guy here, right, is equal to 0.7902, right? And this guy here is equal to 3.2453. So these two are very different. I mean, they're not even close to each other. So the distribution is symmetric. So the conclusion is that the data are not symmetric. Okay. All right. So this completes the solution to question 1, right, of tutorial sheet number 4. Right. Now let's move to the next question 2, which is this one. So you have this data. Again, the data are arranged from the smallest to the largest. This is the smallest data point. This is the largest. Compute the 5-number summary. Right. I'm sure you guys know what the 5-number summary is. The 5-number summary is the smallest data point, the first quartile, the median, the third quartile, and the largest data point. Right. Okay. So question 2, part 1. Okay. The smallest data, which is the minimum, okay, is clearly the first data point, which is 29.140. Okay. The next thing we need to compute is the first quartile. So that is, your P is 0.25. So your R, okay, is going to be P times n plus 1. N is 20 here, so n plus 1 is 21, which is 5.25. So your R prime is 5. So Q at 0.25 is going to be R minus R prime is 0.25. Okay, this is what you get, all right? Now if you put in the numbers, this is the 5th smallest data point, so that will be 1, 2, 3, 4, 5, this one, right? So 36.5. And this is the 6th data point, 6th smallest, which will be this one. Okay. Now if you do the math, this is what you will get. Okay, so this is the first quartile, right? Remember, the first quartile is always Q at 0.25. Okay. All right. So, and the next number in the 5-number summary is the median. Remember, the median corresponds to Q at 0.5. So your your P is 0.5, okay? And your R will be 0.5 times 21, which is 10.5. Okay, 10.5, and your r prime will be the integer part of 10.5, which is 10. So your q at 0.5 will be r minus r prime is 0.5. Okay, this is what you get. Now you should put in the numbers. X10 is the smallest, the 10th smallest data point in the data set that's given to you. Right, so it's going to be 41. This is the 11th smallest data point, which is 41. Okay. All right, now if you do the math for this, you will get the median to be equal to 41.186. So this is the value of the median. All right, the next number in the 5-number summary is the third quartile. Remember, for third quartile is basically q at 0.75. So your p is 0.75. So your r will be 0.75 times n plus 1. Right, so and that will be equal to 15.75. Okay, so your r prime, the integer part of r, is 15. All right, so q at 0.75 is x15. R minus r prime is 0.75 times x16 minus x15. Okay, now you just sub in these numbers. This guy is the 15th smallest data point in the data that is given to you. This is going to be 44. Okay, then this is the 16th smallest data point, which is 44.025. Okay, now if you do the math for this, you will get this to be equal to 44.01975. So this is the third quartile. And finally, the final number in the 5-number summary is the largest data point, which is the maximum. So you should go back to the data. This is the data, right? The largest data point is this one. So it's going to be 51.261. So we've done the 5-number summary just to highlight what the 5 numbers are. This is the first of the 5 numbers, the smallest data point. This is the first quartile, the second. This is the median, the third. And this is the third quartile, the fourth. And finally, this is the largest data point, the fifth. So these are the 5 numbers of the 5-number summary. Okay. All right. Now the next thing. So that's the first part. The second part is to calculate the sample mean and the sample standard deviation. Okay. So let me show you how to do that. So this is part 2. part two of question 2. Right. The sample mean is basically you sum all the numbers and divide by the number of data points, which is 10 here. So in this case, you will. So the first number is 20. So the number of data points is 20 here. Sorry, excuse me. So the first number is 29.140. The second one is 31.131, and so on until the last point is 51.261. So you sum all these numbers and divide by the number of data points, which is 20. And if you do that, you will get this as the sample mean, right? And okay, so that's the sample mean. Now to find the sample variance, if you guys had looked at my lecture notes or the video, you will see I gave you two different formulas for the sample variance, right? One formula is, is this one. Okay. This is one way to calculate the sample variance, right? And another way to calculate the sample variance, which is equivalent to this formula, is using this formula, and these two are equivalent to each other. And actually, I gave a proof in the video that this is equal to this, right? Okay, I'm going to use this one because it's easier. So your n is 20, so n minus 1 is 19, right? And so this one is sum of xi squared, so it's going to be like 29.14 squared. The next one is 31.131 squared, and the last one is 51.261 squared, minus n is 20 multiplied by x bar. We already know what that is 40.6942 squared. Okay. Alright guys, so if you do the math for this, this will be equal to 30.54325. Okay, so this is the sample variance. Now the sample standard deviation is S, which is the square root of S squared, right? So it's the square root of 30.54325, all right? And if you take the square root of this, you get 5.527 up to the 3 decimal places, right? Okay, so that is part 2 of question 2. Okay. All right, guys. Now let's go to part 3. Obtain a frequency table of the data using intervals of length 5 in the range 25 to 55. Hence, plot a density histogram for the data. Okay. All right, let's see how we can do this. Right, so the first, I showed you how to I mean, a histogram is basically like you need to have an interval column, and you need to have a frequency column, and you need to have a density column. Okay, so this, I'm doing part 3 of question 2, right? Now the interval, we're gonna go from 25 to 55. In length of each interval is 5. So the first interval be from 25 to 30. The next one is 30 to 35. Next one is 40 to 45. The next one is 45 to 50. And the next one is 50 to 55. So it's open on one side, closed on the other side. So each of these interval has a width of 5, right? So it goes from 25 to 55. The frequency is basically how many of the data points. So these are the data points you have. These are the data points you have, right? How many of these data points fall in each of these intervals, right? I'm sure you can do this. So for between 25 and 30, there's exactly 1. In this interval there are 2. This there are 5. This there are 8, 3, and 1. So the total frequency must be the total number of data points, right, which is 20. Okay, guys. Now to compute the density, I'm not sure if I told you this in the class or not. The formula for the density is the following. Let me write down in the bottom here. The formula for the density is the frequency. It's the frequency divided by the number of data times the interval width. So this is the formula for the density. All right. So it's the frequency, which is the second column, divided by the total number of data, which is 20. Interval width, which is 5 in each case. The width of the interval is 5. So 5 times 20 is 100. So the density will be 1 over 100 for this one. It will be 2 over 100 for this one. 5 over 100 for this one. 8 over 100 for this one, and 3 over 100 for this one. 1 over 100 for this one. So okay. So this is the density. This is the formula I have used. Remember this formula all the time. So it's the frequency divided by the total number of data points times the length, the width of the interval. Right? Get this. All right. All right. So that's complete. That's part 3. Part 3 of question 2. Now, next is part 4. Excuse me. To do part 4. Oh, we haven't plotted the histogram. I forgot. Okay, I will show you that in a minute. Now, in part 3, we are also asked to plot a density histogram for the data. Now, I will show you that in a second. It looks something like this. Excuse me. You should plot go back to this, right? You should plot the density versus the interval, right? This is it will look something like this. So this is the interval axis, and the y-axis is the density axis. So this is what you will get, right? And if you add the area of each bar, it must be equal to 1, because as you know, in probability 1, one of the things you learn is that the area under the curve of any probability distribution must be equal to 1. And the same thing is true here. That is, you should compute the area beneath each bar here. They must sum to 1. Okay? Alright, so that's it. And alright, now to part 4 of question 2. It's asking you whether you think that the underlying distribution is symmetric or not. To answer the question, just like we did in a previous exercise or question, the best way to answer this is to compute the distance between the median and the first quartile, all right, and also between the third quartile and the median. All right, and compute these two and see how they compare. Okay, see how they compare. So this guy here, this is the median is, we computed that earlier, is 41.186 minus the first quartile is 37.0325, and the third quartile is, is 44.01975, and the median is 41.186. So you can see, I mean, I don't have a calculator with me, but you can see that these two are approximately, these are approximately equal. Yeah, it's not difficult to see without even doing the calculations, right? Hence, the distribution is approximately symmetric, right? Okay, guys, so that completes the solution to question number 2, right? Now, question number 3. Let's look at what that is, right? So, question number 3 is. You have this data set, you have this table, all right? It has 3 columns, the interval column, the frequency column, and the percent column, the percentage, right? There are 2 parts. The first part is for a histogram based on this tabulation with intervals of width 10 starting at 5. Remember, you can see here clearly that the length of each interval, the width of each interval is equal to 10, right? Calculate the height of the density histogram at x equal to 20 and x equal to 80, right? All right. Now let's see. It's not really difficult to do this because this is question 3, part A. Remember that I mentioned in my previous question, right, that the height of the density, right, the density is equal to the frequency divided by the number of data points, the total number of data points, multiplied by the interval width. All right. All right. Okay. So if x is 20, falls in. You should go back. Okay, let me take this here. Right. X equal to 20 falls in this interval 15 to 20. Right. So your frequency is the frequency corresponding to this interval is 142. So 142, and the total number of data points is 500, right? And the interval width is 10. All right. So if you compute this, guys, you will get this to be equal to 0.0284. Okay. So that's for x equal to 20. Now, if you're also asked to find the density when x equal to 80, right? For x equal to 80, so let me say this is x equal to 20. So when x equal to 80, the density will be, again I'm going to use the same formula. The frequency, you need to find the interval. Alright, this interval contains 80, right? And the frequency is 6, right? So it's 6 divided by 500 times 10, right? And this will be equal to, you should work it out, this will be equal to 0.0012. Alright, so this is the answers for part A of question number 3. Now question B, part B. Now consider the histogram based on width 20, starting from 5. Alright, retabulate the data and do the calculations in part A. Alright, so what this means is the following. Now, instead of having intervals of length of width 10, you want to have intervals of width 20. So you've got to combine these two into one, 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 and so on. Okay. All right. Now, for part B, x equal to 20, right? I'm going to use the same formula. Okay. The frequency for x equal to 20 is, if you look at this table, guys, right? You see 20 falls in the first interval from 5 to 25. So the frequency is going to be 83 plus 142. So it's 83 plus 142 divided by the total number of data points is, the total number of data points is 500, and the length of the width of the interval is 20, right? And you should compute this. This will be equal to 0.0225. Okay, that's when x is 20. Now, when x is 80, again I'm going to use the same formula, right? If you look at the table, right, 80 belongs to this, right? And the frequency is 13 plus 6, which is 19, right? So this is going to be 13 plus 6. Okay. And if you do the math for this, you will get 0.0019. Alright. So the differences between A and B is that in A we have used intervals of width equal to 10, and in B we have used intervals of width equal to 20, right? But it hasn't made a lot of difference, because you can see that the density of 0. When x equal to 20, this is the density under A, and this is the density under B. They are similar, and similarly these two values are also similar, right? So what you can see is that the density values are similar. Right. Alright, so this completes question 3 of tutorial sheet 4. Okay. The next one, the next question is this one, but this is slightly outside of what we learned in the class, so I'm going to skip question number 4, right? And go to the next one. And this, as I said, this is slightly outside of the syllabus of this course for this year. So don't expect anything similar to any question similar to this coming up in the exam, right? All right. So I will skip this question, right? All right. So let's go to the next question, which is question 5. So you have the following data. There are 18 data points, right? The first part is to do the 5-number summary and also compute the interquartile range. Remember, the interquartile range is the difference between the third quartile and the first quartile, right? Okay. So let's see how we can do this. Okay, just give me a second, guys. So the 5-number summary. So this is question 5, part 1. The first number in the 5-number summary is the smallest data point, which is 31. Right? The second number in the 5-number summary is the first quartile, so it's Q at 0.25. So you have you have your P equal to 0.25, so that implies your R is 0.25 times n plus 1, which is 19, right? So it's going to be 4 times 4 is 16, so it's going to be 4.75, and your R prime is the integer part of this, is going to be 4. So the first quartile is going to be plus R minus R prime, which is 0.75, multiplied by this, right? Now we should sub in the numbers. The fourth smallest data point, if you look at this data, is 69. The fifth smallest data point is 70. Alright, so this is going to be, if you work this out, this will be 69.75. So this is the first quartile, or Q at 0.25. The next thing you want to do is the Q at 0.5. So we take P to be 0.5. So your R will be 0.5 times 19, right? So this will be equal to 9.5. Okay, so your R prime will be 9. Okay, so Q at 0.5 will be X. The difference between R and R prime is 0.5. Okay. Now just sub in the numbers. Just sub in the numbers, you will get this to be equal to 78. Okay. And the next one is the third quartile, so your P is 0.75, so your R is okay, and this will be correct me if I'm wrong, 14.25, and your R prime is 14. Okay. So Q at 0.75 is gonna be R minus R prime is 0.25. Okay. Now if you sub in the numbers, right, you will get this to be equal to 87.25. And finally, the last of the 5 numbers is the maximum. Okay, and that is equal to 94. Alright, so just to highlight one more time, the first of the 5 numbers is this one, which is the minimum. The second of the 5 numbers is this one, which is the first quartile. This is the third of the 5 number summary, which is the median. And this is the fourth of the 5 number summary, which is the third quartile. And this is the last of the 5 number summary, which is the maximum. All right, so that That computes, or not yet. But one more thing we need to find is the interquartile range. Remember, the interquartile range is the difference between the third quartile and the first quartile. Okay, so that's going to be 87.25 minus 69.775. So that's going to be 17.5. Right? So that completes the first part of question 5. Right? Now the second part. Let's go back to the second part is to use the result in part 1 to draw a box plot and to comment on the shape of the distribution. Right. Right. Now, I'm sure I explained to you guys in the class what the box plot is. Right. You should draw a box plot using the values that we just got. It will look something like this. I don't know if you can see it clearly, but this is what you will get. Now, this middle line here is basically the median. So if you go back to this here, the median is 78, right? So I didn't draw a very clear line, but this is actually 78. You should draw a clear line. It will hit the y-axis at 78, right? Okay, and this line here, this line is the third quartile. Let me draw one more time a better line. This line is Q at 0.75, okay, and this is Q at 0.5, and this one this is Q at 0.225, right? So you see what I have drawn. So this line here corresponds to the first quartile, which was 69.75. This line corresponds to the median, which was 78, and this line here corresponds to the third quartile, Q at 0.75, which was 87.25. Okay, and these two, you should not be confused with what I gave you in the class. These two, this one is known as the, let me explain. This is known as the lower adjacent. I will explain what this is in a minute, right? And this is known as the upper adjacent. Okay, all right, and okay, let me explain how these are computed. Before that, I need to, you may remember in the class, I told you that you should take 1.5, you should take 1.5 times the IQR, you will get something, right? You will get up to this level. You should take this distance here, this distance from this to this is 1.5 times IQR, right? And similarly, you should take 1.5 times IQR from in this direction, right? You will get something up to this level, which is beyond. This is once again, this is 1.5 times IQR. Okay, and if you compute, because IQR is something that we computed in the previous slide. Remember, IQR for this data set is 17.5. So if you use the number that we got for IQR and multiply that by 1.5, and you will see that this is kind of difficult to draw, but let me try my best. What the value that you have here, right, is approximately equal to 43.5, and the value that you have here is approximately equal to 113.5, right? So this is the point. Any point that falls below this is known as an outlier. So these two data points are outliers, and any point that goes above this are also known as outliers. But for this data set, there are no points above this. Only there are 2 points, 2 data points that are below this, which are these two, right? All right, now let me explain what is lower adjacent and what is an upper adjacent. The lower adjacent is the smallest, excuse me, the lower adjacent is the smallest data value that is greater than this level here. This level is 43.5 for this data set. So the smallest data point that is greater than 43.5, you should look in this data set here, right? The smallest data point that is greater than 43.5 is 63, right? Is 63. You can find it somewhere here. This one is this data point here, 63. So the lower adjacent for this data set is 63. And similarly, the upper adjacent is computed as this. The upper adjacent is which is given by this level here, right? Is the largest. Is the largest data value, right? Is the largest data value that is less than this level here, which is 113.5. Okay, and again, you should go back to the data set here. You should look at the largest data value that is less than 113.5 is actually equal to 94. All right, so the upper adjacent is equal to 94, and the lower adjacent is equal to 63. So I want you to be clear about this, right? I did not talk about lower adjacent and upper adjacent in the class, but this is, I only talk in the class. I only talk about these two boundaries. This is the boundary that is obtained by taking 1.5 times IQR from this, which is the first quartile, and this is the boundary that is obtained by taking 1.5 times IQR from this, which is the third quartile, right? So you have these two boundaries. Anything that goes below or above these boundaries are called outliers, right? But on top of that, you have also something called the lower adjacent and the upper adjacent. Right? The lower adjacent, given by this bar, is the smallest data value. The smallest data value that is greater than this level here, which is for this data set is 43.5. Now, if you look at the data set here, right? If you look at this data set, the smallest data point. If you look at this data set, the smallest data point that is greater than 43.5 is 63. So the the lower adjacent is equal to 63 for this data set. And similarly, the upper adjacent is the largest data point that is less than this level. This level is 113.5. Yeah? And if you look at this data here, the largest data that is less than 113.5 is 94. So the upper adjacent is equal to 94. Right? So that completes That completes part 2 of question 5, right? Now, there's also a part of another part of part 2 that is asking you whether the distribution is symmetric or not. You can say it, but by looking at the box plot, the median is about halfway between the first quartile and the third quartile. So you can say that the distribution is approximately symmetric. So because looking at this, we are still in part 2, right, of question 5. You can say that looking at the distribution is approximately symmetric. Okay, it's approximately symmetric because the median appears halfway Okay, all right. So that completes part 2 of question 5. Now the last part 3 of question 5. Let's go to that. Calculate x bar and s, which is sample mean and the standard deviation, and compare with that of the sample median. And comment on the discrepancy between the two. Right. Now, okay, this is part 3. Okay. To compute the sample mean x bar. Remember, x bar, you just sum the data values and divide by the number of data points. So in this case, it will be 31 plus 42 up to the last data point is 94, and divide by the number of data points, which is 18. So this is going to be equal to 75.06. Okay, to compute the sample standard deviation S, right? You can use the formula that I gave you previously, which is 1 over n minus 1 times the sum of xi squared okay, and you take the square root of this, right? So this is going to be 1 over n is 18, so it's 17. Then in brackets you have you have the sum 1 to 18 of xi squared minus n is 18 multiplied by okay, right, and this one you just sum the squares, so it's going to be, if you do the math for that, you will get it to be equal to 16.54 approximately, right? And finally, the median, we have already worked out the median in the first part of this question, which was 78, right? So you can see that if a distribution is exactly symmetric, you would expect these two to be equal, but they are not. 75.06 and 78 are not equal. I mean, although they are nearly close, but they're not close enough, right? So the reason that the median the reason that the mean is smaller than the median is because of the two outliers. So you should go back to the box plot here. You see that there are these two outliers, right? Two very extremely small values, and so that's why these two outliers have pulled the mean to be smaller than the median. So the mean is affected by the two outliers, right? Without the two outliers, the distribution would have been more symmetric. But here it's not exactly symmetric because of the two outliers, right? All right, so this completes question 5 of tutorial sheet 4. The next one is question 6. It has 3 parts. The first part is to show that the CDF of a normal variable is given by this, where phi denotes the standard normal CDF and mu and sigma are the mean and the standard deviation respectively. Right, so let's see how we can do this, right? So this is question 6, part 1. So we are told, we are told that x is a normal variable with these parameters. Okay. So the CDF of x, right, is by definition is the probability that capital X is, right, and this is the probability. Now what I'm going to do is I'm going to subtract mu and divide by sigma on both sides, so you will get now one of the properties of the normal distribution I mentioned in the video on the normal distribution is that this has the standard normal distribution, in other words, mean 0 and variance 1. Alright, and this equal to phi. Phi represents the CDF of N01 at okay. So this completes the first part of question 6. Part 2 of question 6 is to find the quartile function is to find the quantile function corresponding to this, right, and derive the interquartile range. Okay. All right. Now you may recall that the quantile function, which is denoted by this, right, is defined by, I think I mentioned this in a video, in one of the videos. It's defined by this. Okay. So in other words, the quantile function is the value for which the CDF at Q of P is equal to P. Right? And we know from first part that this guy is now, if you take the inverse on both sides, you will get this, right? And if you take the sigma to the right hand side, you will get this. And finally, if you take the mu to the right hand side, you will get alright, so this is the quantile function of a normal variable with parameters mu and sigma squared, right? Alright. We also want to find out what IQR is. Remember, IQR is the difference between the third quartile and the first quartile. Okay. So using this formula, this will be mu minus mu okay. The two mu's will cancel, so what you get is the following: sigma, in brackets you have this. Now, you should read this off the table. I talked about the normal table and how to read them in one of the videos, right? So you should read them off the table. You will get the following. You get approximately 1.34349. Alright, so this completes part 2 of question 6. Right? Now, next part. Part 3 of question 6 is this one, is to use the data set in 5 and calculate the normal based estimate of IQR and compare it with the one we calculated above, right? Okay, now if you return to question 5, guys, you will see that excuse me, just a minute. All right, so this is question 6. Question 6, part 3, right? If you use the empirical estimate, if you use the empirical estimate that we got, that we got for IQR in question 5 was 17.5, right? Now, if we assume that the data are normally distributed and use the formula that we derived in part 2, right, then we will get that is, use the formula remember, in part 2 we got the following formula: 1.349, right, times sigma, but we don't know what sigma is, so we're gonna replace it by S. S denotes the sample standard deviation, right? Okay, remember, S is an estimate of sigma, right? Now, using the value for S that we got in question 5, you should sub it here, you will get 22.31. So this is the estimate for IQR based on the assumption that the data follow the normal distribution, and this is the IQR that we computed directly based on the data, and these two are quite a bit different, right? So this suggests this suggests that the data may not be normally distributed, right? Okay, you follow, guys. This is the estimate based on the assumption that the data follow the normal distribution, and this is the estimate purely based on the data. Since they are quite a bit different, you can say that it shows evidence that the data may not follow the normal distribution, right? So that completes question 6. The final question on sheet 4 is this one. By considering the case of odd and even n, show that the median, or derive the median for the data set x1 to xn. All right. Now, you may recall from one of the videos, right? This is the formula that I gave for the median of a median for any data set, right? So this is the formula for the pth quantile or quartile. Right, now we want to derive a formula for the median. So, which means P corresponds to 0.5. Okay, now I want to show you how to do it. So this is question 7. I want to consider two cases, right? So P is a half, okay? P is equal to half. And the first case I'm going to consider is that assume that n is the sample size, is odd. It's an odd number. Alright? So your R prime, which is this one, is half times n plus 1, the integer part of it. Now if n is odd, n plus 1 will be even. And an even divided by 2 is a whole number. So this will be equal to this. And your R is also equal to this. So using this formula with P equal to half, we get X R prime is, okay. Now R and R prime are the same, so this term here is 0, alright? Okay, so this is the formula for the median of a data set when n is an odd number. Now let's do the same thing when n is an even number. So let's suppose n is even. Right, then R prime is okay. So if n is even, n plus 1 will be odd. And an odd number divided by 2 is not a whole number. Right? So this will be actually, the integer part of this will be n over 2. Because n is an even number. Right? Okay. Now using this formula one more time with P equal to half, this is what you will get. So Q at half will be X R prime plus R minus R prime, which is this minus this, is a half, right? Then in brackets, right, this is what you get, right? Now this you can simplify a little bit, so this will become half okay. Alright, so the median is equal to this if n is a odd number, and equal to this if n is an even number. So in summary, so let me summarize what I just did, right? In summary, we can write the median as follows. So it's equal to okay, and is equal to okay. So this completes question 7, and so also completes the solutions to tutorial sheet 4.